Okay, thank you to all of you that in the last minutes of today, ITSEC, you are here and would like to hear for our project. Actually, our project is Modeling and Simulation Group 147, and we call it Dynamic Project. Why dynamic? You'll see after little. Our project is called Modeling and Simulation Decision Making Support and Data Analysis Platform for crisis and disaster management processes and climate change implications. What is important to say before we start, actually we will not go in deeply in details about the project and how it developed and etc. Most important is that the main goals of this project are three. First of all, we are trying to make assessment of disaster risk management as a part of NATO operation planning process. The second one, and third one, actually, you can see on the screen, disaster management as during NATO military operations, and the third one, education and training. In all three bullets, what you can see on the screen, me, Colonel Orlin Nicolou from Crisis Management Disaster Response Center of Excellence, and Major Kostadin Lazarov from the Crisis Management Crisis Management and Disaster Response Center of Excellence, will present you in next 20 minutes. On the first screen you can see the main project schema, and we'll try to pass through it. But first of all, I would like to give the microphone on my colleague and to explain two conceptual, innovative, synergized idea first of all, and after that I will take it again.
Thank you, sir. It could sound a little bit ambitious, with very big scale, but yes, actually it is. And I like just to go back for a second why it's a so-called dynamic project, because actually we'd like to investigate, we'd like to assess two dynamic processes. First is the disaster event. You know that as the NATO military operation, it's time and space dependent. At the moment, of course, we perform disaster risk management before operation, during the planning process, but it's a little bit static. For example, it could be done on a map, just drawing a circle around a chemical plant or something like this, and of course everybody should avoid the specific area. Instead of such a simple approach, we'd like to have a really surgical assessment of the situation, and we are going to investigate the influence of one dynamic process, the disaster event, over another dynamic process, NATO military operation, and to see what could happen with and without some precautions, without preparedness, or with preventive measures. The next dynamic idea is generation of the response plan. It should be generated dynamically, and it means that it will be generated according to the specific situation, to the specific conditions of a particular disaster, which could occur during the operation or while we are just assess what are the disaster risk threat before the operation. So, trying to do that, we would like to reduce the human subjectivism. We'd like to collect as much as possible expertise and experience, and at last we'd like these response plans to be generated by intelligent engine combining adaptive industrial control logic with predefined triggers and thresholds for reaction. At the bottom of the slide you can see one industrial equation of PID algorithm for reaction. It's something very common and could be applied in our case also. Why? because we don't want to reinvent the wheel. We'd like just to have something existing as control logic and to apply it in our specific case. The graphic is very interesting because the acceleration of this function is constant. So at the beginning of the graphic we have really small impact of the disaster, and at the end of the graphic here we have significant impact. However, we could predict this, and this is one of our main ideas, just to use mathematical models of the different disasters, but later Colonel Nikolov will explain it in more details. So again, the acceleration is crucial here, and it's very, very, very important for us.
Okay, now I will try to explain this schematic, what is our idea and what we would like to achieve. Actually, from we're using different type of data, what is existing everywhere actually, from real-time data, from sensors, or we can use historical data. And everyone, you know that university, government and all government organization has different types of models for different types of disasters. We don't want to create a new type of model that we would like everyone decision maker to use the model which he would like and addict to work with it. That's why all this data is coming to disaster model, and after this disaster model we have a lot of data how to predict, and but we cannot simulate and we cannot estimate how many victims, how many injured, what kind of materials losses we will have through that disaster or that event. That's why our idea is to create that disaster module, which put inside this data on the exit we put on the simulation system, where we really would estimate all kind of victims, losses, and etc. Unfortunately, one of gap what we mentioned before, and what we found was that for disasters we don't have federated object models. We don't have any forms for any kind of disaster except for CBRN. That's why our first experiments and tests made it on CBRN event. After federated simulation systems, actually the idea is to use exercises like Viking, like NATO exercises, which have a different type of federation with different simulation system, and every one nation or organizations to use his own simulation system. Through our disaster module, all informations to go directly to that federated through HLA or DS or for civilians is a completely different story, but that is not the point of that presentation. On this stage we are working on that what I explained now, but also our project in future, the idea is to have also standard operational procedure inside, and together with this module for filtering and distribution, and define different triggers. We'll not stop on this one, because if we're going deeply we will lose you as auditoria. That's why our idea is more to present and to demonstrate what we achieve till now. When we have these standard operational procedures and dress code models, using federated simulation system and disaster module, what already put the data, the disaster on the simulation system, on the federation actually. Now the decision maker could estimate the disaster risk management before the operations, or when the operations occur, we can use it through the operation as a disaster response system. But as we started with this one, the third option was for education and training. That's why, for our purposes, we'll start on that point, and we'll try to use it for education and training of decision makers. Because, as you know, in NATO, we have a lot of, and we can see in this huge hall that we have a lot of simulation and system, but most of them are for military purpose. We don't have too much systems for disaster management, or if we have it, then we have it in some kind of disaster, not like all kind of disaster system. That's why we don't want to use it, and don't want to renovate some kind of new simulation system. We want to use what we have on the market, and just to be more flexible. Maybe it's good to go on the next slide. Because Kostadin actually made it this disaster model, I'll give again the microphone to him to explain it.
Thank you, sir. As Colonel Nikolov already said, we'd like to have external engine for prediction of the disaster, and using such approach, we can publish the disaster event as HLA object into the federation, and we can have in each connected simulation the same object, the same HLA object. So it's a really good advantage. The developer of the simulation is not responsible to have a different disaster model. It could use our, and the HLA object is just published into the federation. It's not only visualized, but the object has all attributes. I mean, the toxic gas, which we will see in a few minutes, has really significant impact over our forces. So, as Colonel Nikolov said, we started with Siberian incident, and this is the interface of the disaster module. Here you can tune, or you can input the specific data for specific gas, for example. This is data from database. We have data for the weather condition, location, etc., etc. Yeah. Then this data goes to the engine. Actually, in our first mathematical model was for chemical incident, and was very simple with few equations, just with few equations. Later we used results generated by HPAC. If you are familiar with this application, it's made for DITRA, and produces really good results. And the computed results are published into the federation. It was necessary to build specific bridge which transform the generated by HPAC XML files into the HLA object. But finally, as Colonel Nikolov said, at the moment there is not existing disaster form. I hope that it will be developed soon, and the most important thing is the industry to implement this form into their applications. We are going to present already achieved results. We have on the screens we have one and same scenario with same orbit, with same list of orders, but in one of these cases, I don't know in which one actually, we have Siberian incident. Red forces just hit one chemical plant, and we will see what is the difference in the performance of the blue forces, because, as I said, all other conditions are the same. Как се это нещо? Да, аз го пуснах. Okay, on the upper screen actually you see how we started our disaster module, and right now, because the simulation is speed up, you can see the chemical object here with 3 different contours. It's related with the toxicity of the chemical gas, and of course our artillery, blue artillery, is affected, which is not good for the final result. Here you can see that blue forces are already affected, and we have almost 50 soldiers dead. So completely different results, and with such approach we'd like just to prove our concept, because we have, as I said, 2 dynamic processes: the operation and the disaster, and later you can try to avoid such scenario. For example, we just can replace our artillery, we can change the position, or we can try to enhance the chemical defense, etc., etc. So that is our first demonstration.
Yeah, if you understand that what is important about this cloud is exactly that inside this cloud we have data. What is not possible if we make some kind of disaster like flooding, fire, forest fire, or earthquake, or etc. We'll have just a picture. That is the difference for CBRN. That's why we are stopped on CBRN. Actually, we made it this experimentation on twice. First, we make an experiment in Sofia in May, and after that we made second experiment in Bydgoszcz in Poland just a month before the ICEC. On that experiment we succeeded to prove the concept initially, and to include to use JCATS, Master Sword, our disaster module, of course, VBS3 from the University of Genoa, ST Chrysum, Cobra, C2R as a C2 system, HPAC and ST Chrysum again as a model. Here is like a simulation system. The interesting is that here in green everything is connected in federation like through HLA, but HPAC is not possible. They could transfer data through XML files. Good news is that disaster modules could be put in the federation through HLA, and also to receive the files from systems which are not possible to put to be federated on federation. Okay, because I see that this is not working properly. We will continue with the dynamically generated response plans, and that is the future actually of the project, what I explained just on the schematic. It's an initial phase, and I'll give again on the Kostadin the floor.
Thank you, sir. We'd like to start with something simple. In our case, we have a list with objects which are interesting for us. It could be our forces, enemy opposing forces, it could be parts of the national infrastructure, it doesn't matter. But we have the predefined thresholds for each of these objects in our list. When we publish the HLA object, the disaster, into the simulation, its responsibility is to calculate the impact over the objects. So the simulation will give us reports, and we will analyze, is it above the predefined thresholds or is below. If it's above, of course, we have to take some precautions, to take some measures. And in order to do that, we start to develop a database with SOPs in it. Each of the rudimentary measures of this database has additional metadata, and using this metadata we can filter the appropriate measures for this specific event, for this specific impacted or affected objects. So finally we can propose to the decision makers list with measures, and he or she could apply or reject them. When a decision is made, of course we can close the loop back and we can see what will be the scenario with applied response measures. It's a really great opportunity to save time, to save lives and resources. And the next step is to use artificial intelligence because it will give us more comprehensive approach. As you can see, this is our approach, how the response could be generated. We have a disaster event, and we have to generate our plan, and this is our proposal how it could be done. It's close to the .mlfp approach, but it's not the same.
Okay. What is here is important that all kind of what the decision makers needs to take one decisions, it's included inside. Of course, it's not completely developed, but we started on that phase. Just before to finish our presentation demonstration, we would like to say some words about the group. Sorry, maybe. While I'll explain, Kostadin will try to make a demonstration with SIT-aware and how we use also C2. I don't know where to stay, not to make a microphone. But our group started 1 year ago, 1 year and a half actually, in March 2016, and on board together with Austria, Bulgaria, Germany, Slovenia, and United States of America. Also, through the year, we have on board Modeling and Simulation Center of Excellence, Crisis Management Disaster Response Center of Excellence, JCBRN Center of Excellence, and Defense Against Terrorism, and also NCIA, JFTC, very good and very important role, and other NATO structures. As a contributing partners, what is important in that project that is open not only for PFP and NATO nations, but also it's open for industry, and we have a huge interest, and till now on board we have also IBG, Master Sword, VBS Free, I'm sorry to miss someone, SIT-aware, Symantec actually, and also universities as University of Genoa, University of Bundeswehr, Bulgarian Academy of Science, and etc. On the other screen now Kostadin made this federation, and practically you can see when if you have any questions, and after the presentations to see and touch, as I should say. I would like to thank you for your attention, and sorry for the last presentation on today, but if you have any questions, we'll be glad to answer them. Thank you very much.